Is it done?
Yeah.
Okay, science time. Today we're talking about, let's just call this one motion. We're going to talk about several things. Motion and the laws of motion. The objective is describe forces and their effects. That's still true. We're still describing forces and their effects. We're going to start by talking about motion in general. Define motion for me. Someone raise your hand if you would like to define motion. Dave, let's hear what you say.
Okay, I have to look back at my notes because I know I wrote it down.
Well, let's let Will do it for the sake of expedience.
Motion is the movement of...
A synonym for motion is movement. So that's a fine definition. We all know what movement means. And so motion is movement. Let's be a little bit more specific though. How can I know? Here, I'm going to play a trick on you. Everyone close your eyes. It's a Halloween trick. Close your eyes. Close your eyes! Don't yell. Close your eyes. Are you closing them?
Yes.
Can I open your eyes? Look, I'm in a different spot. Did you see that?
Good
That's a good trick. Well, how do you know I moved? You didn't watch me move.
Because we could hear you.
Because the laws
Okay,
of motion.
no, I was trying to be quiet. No, how did you know I moved? What changed?
Your position.
My position. Okay, so let's try it that way too. Change in position. That was an excellent trick, if I do say so myself. It's a change in position. That's how we know something moves. Even if we don't see it, a stupid person or a dog, the dog has to see. The dogs and stupid people have the same thought processes. Dogs have to see when something is moving to know that it moved. I mean, they might be. I have a good example. A cat. There's videos all over TikTok of if you have a cucumber and you put it behind your cat, it will be afraid of the cucumber because it wasn't there when the cat was facing that way, and then when it turns around, that implies to the cat that something has moved, right? Because it knows the cucumber wasn't there before, so it changed position. And that makes the cat think, oh, the cucumber can move on its own, I'm going to jump, and then it jumps. It doesn't think all that through because cats are stupid. But it does, its instinct is something has moved because it wasn't there before.
I'm scared now.
Okay, so motion is when something moves, but it's a change in position. Okay, motion is a change in position. Have we already talked about what is necessary to describe motion or precision? I think we did, didn't we? I confuse what I've talked about with the freshmen with what I talked about with you guys. To me, they're still 8th graders. So they still act like it, for one thing. What do we need to describe motion? How can we describe something's position correctly? Let's talk about this. Position. How can we describe something's position? We need 3 things. If you're going to accurately describe my position, what do you need to say? What is it? Tell me where I am. What's my position?
You're standing up straight
And
on
close to the corner. In the southwest corner of the classroom.
So Gabe gets us something. You're all on the right track. What is it that Gabe said that was more specific than what the others had said? Which is a what? Direction. So one thing we need is a direction. I'm going to make that number 2. Direction. You can do these in any order. They're not in order of importance. They're not in alphabetical order. You can do them in any order, but I like to talk about the first one first. What else do we need to describe? He said southwest corner of the room. Am I literally inside of the corner?
No. You're near it.
Okay, near, implying a what? If I want to be very specific, I wouldn't just say near. I would say
approximately.
Yeah, but that's the opposite of specific.
5 inches.
There you go. Don't use inches because that's the units we don't use in science. But if I were to say that right now I'm 1.1 meter away from the wall, what is that describing? Yeah. Yes, you're right.
Distance.
I'm going to call it distance, but you are right, Hunter. Length and distance are used interchangeably for this. But now the problem with that, the reason we need a direction is because if I'm 1 meter, this is 1 meter. This whole area is 1 meter away from that corner, right? So how do I know which direction I am from the corner? Well, I'm, as Gabe said, southwest, roughly. We describe the direction to describe which one of these many, technically infinite points that's 1.1 meters away from the corner I am, is the direction. Okay, so we have distance, direction, and then all of this relies on what? What? If I just say, I'm 1.1 meters southwest, what's missing there that I have to have?
There's a wall.
Yeah. What's the question you ask? If I say, my mom is 3 feet above, I've used the distance and the direction. Yeah, but you're answering the question you haven't even asked. What is the question you need to ask to know where my mom's at?
How is she 3 feet above?
How is the wrong question?
What is she
Okay.
standing on?
Yeah, the what? Though?
Where?
Objects
Where?
around them.
Where
Yeah.
you're at.
Yes. Yes. Sorry. Well, Carson, you didn't say anything yet.
Position.
Will. We're using all these to describe the position.
Boundaries.
But the question, I'm not looking for an answer. I'm looking for a question. I'm going to say, again, my mom is 3 feet above. My mom's 3 feet above.
On
You
top
have to
of
say-
what? On
Yeah,
top of
yeah, exactly. Above what? And so the answer to that question is the reference point. You need to have a reference point. What is the reference point for my position here? I'm 1 meter
Meter
southwest
away from the wall.
of the corner. I'm 1 meter southwest of the corner. The part of that, that's the reference point. My mom is 3 feet above the floor. Maybe she's lying in her bed. I don't know what she's doing. Of course, I haven't seen her for years. She's 3 feet above the bed. We'll say that's the reference point. My dog is probably 10 feet above our kitchen sink because she's in her little doggy bed, which happens to be above our kitchen. I don't know. That might not be true. I have to think about the layout of my house. But the reference point you have to have a reference point. Describe real quick, very quickly. Let's try for 30 seconds with your partners. Describe your position accurately. Using all 3 of these things, do it now. I'm going to pause this. No, I'm not. 30 seconds.
Away from
I am approximately.
I'm in the west. 3 meters. So I'm about 3 meters away from the
You don't actually need order. I have my gavel. You order in the court. Okay. No, not that I need a horse. Game. Order. Okay. Kimber, what did you say?
I said I was roughly, a few centimeters, I want to say north of the wall.
There you go. 3 centimeters north of the wall. Okay. We do this all the time without thinking of it. What if I just say, if you. I'm trying to think of one that might come up in your daily life.
0.
Okay, where do I park my car? You do this without even checking. You might say something like, I'm in row 2 about halfway across the parking lot from the front door of Walmart. Right? You're giving a direction, a distance halfway across the parking lot, reference point from the front door. You do this all the time without even thinking about it. Position needs a reference point, direction, and distance to describe accurately. These are all necessary.
Like I'm a few feet behind you.
Yeah, but feet are valid in this measurement, but that's not what we use in science, right? You use the scientific.
I'm a few meters behind you.
There you go. Yeah, you would say, yeah. Good, yeah. Because there are other directions besides north, south, east, and west, aren't there? What are the relative directions?
North, south.
No. Those are absolute directions. What are the relative directions?
Southeast.
No.
Up, down, left, right.
Yeah, up, down, left, right. What are the other two?
Backward.
Forward and backward. If I say, as Gunnar did, which is a great example, Gunnar, I'm a few meters behind you with a knife. That is a few meters behind you. A few meters behind you. Even something like right behind you. The right is telling a distance, right?
Yeah.
It really is. It's not
It's
an accurate distance, but right behind you. That's something we would say all the dang time. I'm right behind you. That is literally giving these things right behind you. Right behind you. Distance, direction, reference point. Who else wants to share their example? Haley, do you want to share what you said?
16,000 meters.
I said that I am I don't know how many meters, somewhat meters
one and a half.
away
One and a
from
half.
the west wall. 6 directions. Oh my gosh.
You got it. 1.5 meters west of the west wall. There you go.
Okay.
This is the best.
Yes, sir.
That's okay. She's still roughly 1.5 meters from
Uh,
Will, really.
I said I'm half away from the back wall.
Okay, 1/2 meter away, but if you just say away, that's not a direction. You could be
Half
outside
away.
the building, couldn't you? So you have to say 1/2 meter west of the east wall. Okay, good. Questions about any of this? How does position relate to motion?
Because it's the movement. Like,
I have
well,
it. Here's
it's
the
a
thing.
change in position.
There you go. Thank you. You were getting there, Kesslin. Motion is the movement, but position relates to motion because motion is a change in position. Okay. How do we measure motion?
Newtons.
No.
Speed.
Velocity.
Speed and velocity. So let's talk about those next. To measure motion, we use speed and velocity. We've talked about these before, I know we have. Velocity is speed and direction, whereas speed is distance divided by,
Bless you.
God bless you, time. S equals d over t.
What about acceleration?
We're getting there in a second. Speed equals distance divided by time.
Bless you.
And then velocity is speed in a certain direction. I distinctly remember telling you guys this. If I have a speed, if I say I'm moving 30 miles per hour, first of all, what's the implied reference point? I didn't say I'm moving 30 miles per hour relative to a bicycle. What is the implied reference point there?
That you're going 30 miles per hour.
Relative to what, though?
Relative
To...
fully stopped. Fully.
Yeah, but what is something that's fully still that we're always comparing our motion to if we don't imply the
road, the highway,
the ground, the earth, the planet Earth. We're usually talking about our motion relative to planet Earth. If we're being specific, how fast are you moving right now? Well, motion is relative, so you're moving 0 meters per second, 0 miles per hour, 0 anything relative to Earth. But are you moving relative to the sun? Yeah, you're moving thousands of meters a second relative to the sun. Do you see what I'm saying? Motion is relative. Write that down, please. Motion is relative. Motion is relative.
I one time pressed the space bar 44 miles per hour.
Nice. Motion is relative. That means that we have to tell what we're relating our motion to. If we don't, it's implied that our motion is related to what? I just said it. No, not nothing.
Nothing.
No, not nothing.
The Earth.
The Earth. The Earth. Motion is relative. If we don't specify what we're relating our motion to, it's implied that we're relating to planet Earth. So what's your motion relative to Earth right now?
0.
0. What's your motion relative to the sun?
0.
No. Lots. Because Earth, the whole Earth is going around the sun. So your motion relative to the sun is very, very, very fast. What's your motion relative to the center of the galaxy? It's even faster because the whole solar system's going around the center of the galaxy. Okay? Motion is relative. You have to specify. When you're going down the highway, you would say, I'm going 65 miles per hour. Well, what's that relative to?
The Earth.
The Earth. Are you going 65 miles per hour relative to a car in the other lane? No.
Yeah.
No, you're going a different speed relative to that car.
You're going most likely the same speed.
Yeah, so if you're going the same speed as them, what's your motion relative to them?
0.
None. Exactly. All motion is relative. To make it even a finer point, you sitting in the car, what's your motion relative to the car?
0.
0. What's your motion relative to the ground?
65.
65 miles per hour, or whatever speed the car's going. Okay. Velocity is just that, speed and direction. So if speed is distance divided by time, what units do we use to measure speed? Speed units are...
by direction.
Yeah.
Mile per hour.
Yeah, miles
Or
per
if you're in
hour.
kilometer per hour.
Kilometers per hour. These are both what? A what unit divided by a what unit?
Distance divided by time.
Yeah, so speed itself is distance divided by time. Speed units are distance units divided by time units. Okay, write that down somewhere. Speed units are distance units divided by time units. What's another example then? Could you make up a crazy one? What's another example of a speed unit that might be kind of crazy? Well, all we need is a distance unit and a time unit. Go ahead,
Wait,
Will.
speed units or what?
Distance units divided by time units. What?
1 million miles per hour every 1 minute.
Well, but miles per hour is already a speed unit, so we can't use that. It has to be a distance. Yes.
Light years per hour.
Yeah, say light years per hour. Physically, literally impossible. Well, I mean, not really, because you can measure it. You could be moving 0.00000000231 light years per hour. But yeah, this is a distance unit, light years, divided by time unit, hours. What's another one? Hunter, can you think of one? What's our formula? It must be a what unit divided by a what unit?
Hour.
A speed unit.
A distance.
Or
But they have to be a distance unit
yeah,
divided by a
hour.
time unit. So what is? Give us an example, Hunter.
You could be surfing, like, I don't really know.
What's another example of a speed unit? Yes.
Meters per second.
Meters per second. What's another one?
Walking.
Nautical miles. I think it will spell in nautical miles per hour. That's actually called a knot. But yeah. Look.
1 million steps a week.
Steps. That's not a great one. Per week. Sure. Yeah, steps are roughly a distance. People have different lengths of steps, but yeah.
Beats per minute.
No.
What?
Because beats are not a distance unit. It has to be a distance unit. What's another distance unit?
Feet per hour.
Feet per hour. Good, good. Okay, so all speed units are distance units divided by time units. Questions about this? How do we measure motion?
Speed divided
Divided by.
And what's velocity? How do we measure motion?
Speed.
Speed. What is velocity?
Divided by time.
No, what is velocity?
Speed and direction.
Speed in a certain direction. You got it, Kesslin?
Wait, how do you measure speed?
Speed units are distance units divided by time units. We usually use things like meters per second or miles per hour, but it could be any distance unit divided by any time unit. And then velocity is speed and direction. So if I was going 60 miles per hour, that's a speed. 60 miles per hour down would be a direction too, so it would be a velocity. Okay? Will says earlier, what is acceleration? Let's talk about acceleration.
Acceleration is.
We covered that.
Yeah, we did.
Faster.
Yeah, we did. We
Yeah.
covered all this, in fact, but y'all are acting like we ain't done. Acceleration is change in.
Motion.
Let's specify. How do we measure motion?
Velocity.
Velocity. So change in velocity. Acceleration is change in velocity. I know for a fact. I have told you guys. Here are the 3 ways something is accelerating. Here are the 2 ways something is not accelerating. We talked about that with forces. What are the 3 ways that something can accelerate? Give me one. Anyone. What's one way an object can accelerate? What's one way an object's motion velocity can change? Kimber?
Changing direction.
Changing direction is one. What's another one? Faith?
Increased speed.
Increasing speed. What's another one? Gunner?
Slowing down.
Slowing down or decreasing speed. Those are the 3 ways. I'm not going to write those down because we've already written them before. So what are the 2 ways an object is not accelerating? Gabe.
Staying the same speed.
Same speed in a specific direction, which is constant direction. It doesn't matter. It has to be the same direction. Same speed, same direction.
Constant is what?
Constant just means it stays the same. So constant velocity, which means it could be constant speed in a straight line, or what's the other way an object is not accelerating, Gunner?
Just staying still.
Just staying still. Good, good. We have talked about acceleration. What causes acceleration, by the way?
Change in motion.
Change in
Well, acceleration is a change in motion, but what causes all accelerations?
gravity.
Not always gravity, but always a
Force. Net force.
Always a net force caused by a net force. Let's break it all back down. Acceleration is caused, so we're starting with net force, which you've already talked about. You just took a test over this, so you should know about net forces. You should know about net forces. Net forces cause acceleration, which are a change in velocity. Velocity is a measure of
Acceleration.
velocity is a measure of
Speed.
yes, but both of those are measures of. Here, you just have it written
How
down.
fast you're
Motion.
Motion. They're both measures of motion, and motion is a change in position. There you go. Okay, so we broke it all back down. Let's talk about Newton's laws of motion. We're going to talk about them very briefly because we're running out of time a little bit. We're just going to do a real basic rundown of these things. Newton's 3 laws of motion. This is a survey level thing. I have talked in depth about this pretty much for the entire last month in these classes, physical science and physics. If you want to learn more about Newton's laws of motion, one, you need to read your exploration. You have to do that to pass this test. Because this is just going to be a survey level to make sure everyone's on the same page with both of them. But if you also want to learn more about them, you want to hear me talk about them because you have some kind of craziness or something, you can watch the videos I have on the YouTube channel from physics and physical science. They'll say Newton's first law of motion, Newton's second law of motion, Newton's third law of motion. Okay? But for now, we're just going to write these down. Newton's laws of motion. There are 3. The first one, an object in motion tends to stay in motion, and an object at rest tends to stay at rest unless acted upon by an unbalanced force. Have you heard this before?
Yes.
Yes.
I heard it in a movie one time.
Oh, good.
I binge watched the entire series.
I'm not gonna.
The big thing.
An object in motion tends to stay in motion, and an object at rest tends to stay at rest unless acted upon by an unbalanced force. Is this in motion or at rest?
Rest.
What will it tend to do?
Stay in rest.
Stay at rest. Unless
It just hit.
it's acted upon by an unbalanced force.
Yeah.
So, at rest, is it accelerating?
You just touched it. So
Okay, is it accelerating if I don't know? Is it accelerating?
No.
No. So is there a net force acting on it?
No.
No. Are there forces acting on it?
Yes.
Yes, they're balanced forces.
You
What are-
holding them up. Holding
Yeah,
it up.
the balanced forces acting on this marker are the normal force provided by my thumb acting up and the force of gravity acting down. Yeah?
With your middle finger.
If I know gravity's not acting from my middle finger, the earth is acting on it gravitationally. Now if I let go, if I remove the normal force, will the forces still be balanced?
No.
No, they'll be what?
Acted upon by an unbalanced.
It'll be unbalanced force. Ah! So when it was doing this,
Then it was pulled down by gravity.
look, when it was doing that, was it at rest or in motion?
In motion.
It was in motion. So it'll continue to be in motion unless.
Acted upon by an unbalanced.
So when it hits the ground,
It's
it stays there.
no.
Stay. You
Hey.
Is acted upon by a balanced force?
What was the unbalanced force that caused it to stay when it hit the ground?
The ground.
Yeah, the normal force is now acting on the ground. Look, is it at rest? Now it's again at rest.
Yes.
Only balanced forces are acting on it. Okay?
I'll cut a hole.
There's a word for this. The one word you need to know for Newton's first law is this: inertia. I-N-E-R-T-I-A. That's the Latin word for lazy. Yes.
Technically, when you were still holding it, it was still in motion because your arm is shaking.
Yeah, well, I'm doing my best. Yeah, you're right, but yeah, I'm doing my best. Inertia. Latin word for laziness. How does laziness apply to this?
Staying in one spot.
Yeah, basically, it's going to keep doing whatever it's doing unless it's forced not to. There's an idea in psychology of sleep inertia, which is where you, an 8th grader, if you are already awake, it's 11 o'clock at night, you should be in bed, but you're already awake, and so you tend to stay awake. And then, it's the next morning, it's 11 o'clock in the morning, you should be awake, but you tend to stay asleep because you're already asleep. Does that make sense? It's the same thing. Obviously, that's not a physical law, that's psychology, so it doesn't mean anything, but it's inertia. Inertia means laziness. Things tend to keep doing what they're already doing. That's inertia. Okay? Newton's second law is, do you have questions on Newton's first law? Sorry, I should ask. Are there any questions about Newton's first
That
law?
was just the first one?
That was the first one. Newton's second law is an unbalanced force.
I was just watching the video.
You need to write it down, right now. Don't be lazy. Don't be inertia.
I wanna
An
be
unbalanced force causes an object to accelerate in the same direction as the force. An unbalanced force causes an object to accelerate in the same direction as the force. So when I dropped the marker, which way was gravity acting when I dropped it? Down. And so which way did it accelerate?
Down.
Down. It's as simple as that. What if an object is already moving this direction, and I put a force on it this direction? Does that mean it automatically starts moving the other direction?
No.
No? It just means that I'm accelerating it this way. So it can still be moving this way, but accelerating this way. What would that be like? It must be then what?
A change in motion.
Yeah. But if it's moving this way and accelerating this way, it is doing what kind of acceleration?
Reverse.
No, it's not changing direction. It is just moving this way, but it's accelerating this way. It is accelerating, but it must be doing what kind of acceleration of the three kinds?
Slowing down.
Slowing down. So I'm applying a force this way. That's like if you and your girlfriend are riding your bikes, and your girlfriend breaks up with you. She's going to leave the other direction. So you hop off your bike, and you're pushing her. You're trying to slow her down. So you're applying a force on the bike, but she's still trying to leave. You've been in this situation before, I would imagine. She's still trying to leave. So you're applying a force, but you're not causing her to go the other direction. You're just causing her to slow down. So the force and the acceleration are still in the same direction, but it's just causing her to slow down. This is expressed. We'll talk. Hush. We're still,
I mean, switch.
we'll talk about this more in depth, certainly when you're in physical science, but this is expressing the equation F equals ma. What's the F stand for, probably?
Force.
Force.
I mean force, yeah.
Force, what's the M probably stand for?
Motion.
Mass.
I mean
And
mass.
the A probably stands for?
Assembly.
Acceleration. So once again, force equals mass times acceleration. We will talk about that more next year, but for now this is good enough for you. And the third law, you've definitely heard of this one. Newton's third law is for every action,
There was an equal and opposite reaction.
there is an equal and opposite reaction. I do encourage you to watch the videos that I've been making lately about these because I've done it for every other class. This information here will be enough surface level information for you to do well on your test. But if you are interested in this and you want to go deeper, I've talked about this in depth with my other classes. Effectively, if I push on the wall, what happens?
Nothing.
No, not nothing. If I push on the wall, the wall pushes back. That's why I don't go through. If I push on the air,
It doesn't push back.
it does a little bit. What do we call that?
Air
Air resistance. But it doesn't have the integrity to push back with the same force, right?
It's like, I don't
Hunter.
care.
Did you have to memorize all those?
No, I just have them memorized because they're important to me. You have to memorize them for your test tomorrow. No, your test on Monday, sorry.
You actually have to memorize them and write them out?
Yeah, you don't have to, well, you should know them. An object in motion tends to stay in motion, and an object at rest tends to stay at rest unless acted upon by an unbalanced force. An unbalanced force causes an object to accelerate in the same direction as the force. For every reaction, there is an equal and opposite reaction. These are Newton's laws. Do you have questions about these? Question, you just did. What was your question?
I don't remember what I said. Oh, I don't remember.
We're going to do a lab about all of these. Probably, we'll try to start it tomorrow and finish it on Monday would be my guess. And your quiz will have to be Tuesday because tomorrow is shortened. Do you have questions about any of Newton's laws? We had to talk about motion, velocity, and speed first because they are part of these. Those are basics that we rely on to know about these. But these are what this lesson is actually about, okay? How will you learn more about this? How are you required to learn more about this? What's one way? You have to watch, well, you don't have to watch this video. You don't have to watch these videos. But what do you have to do? You have to
Read your explanation.
read the explorations and
Do your
do the explorations, including the lesson itself. You have to do those. They will be due tomorrow. Yes. Whether we go over them tomorrow or Monday, they are due tomorrow. Questions about that?
Yes.
Can you force her
What is
to
it?
respond?
Fine. Yes.
Can you force
I have
her
a
to
question. Is time different on different planets?
No.
It's the same everywhere.
Time is the same everywhere. The way we perceive time can be relative. There's an idea called the theory of relativity. Is it?
No, it's not.
You have explorations to do.